Now that I have fooled with everything inside that I care to fool with, sort of ever, I am ready to get into calibration. And following along, it says to set this for a 6v6 tube. So for a 6v6, I am on type 3. The filament is set for 6.3. C for the load, set to 29, right about there. Up 3, 4, 5, down 1, 7, 8. Turn the tube tester on. Set the line adjust control of the tube tester for a voltmeter reading of exactly 6.3 volts. Tube tester is on. Insert voltmeter leads into pins 2 and 7 of the 8-pin octal socket. 2, 3, 4, 5, 6, 7. Line adjust to 6.3. Okay, so I'm at 6.3. Adjust R10, the calibration control mounted until the needle of the tube tester points exactly to the center line test mark. I'm going to start with it in the center position and see how that does. Okay, that made it worse. Okay, consulting the schematic. That's my calibration trim pot there, and it's all the way maxed out at 1.2K. And the question I'm having is, should I bump that up with something else that's larger? And where would it need to go? Got a 1/2 watt 1K resistor here. Snip that off. I've removed the red wire, this guy, that was connecting that center wiper all the way up to this leg on the trim pot. Replace that with a 1K resistor. Plugged in, turned on. Look at that. It's just about perfect. Okay. So according to the instructions, that is now calibrated. For my last step, I picked up some of this electronics cleaner, and it comes with a handy dandy straw. And I used that to go through and spray all the bat switches and the short and test switch and the off-on switch as well. So it seems to be working, and I'm going to test my old faithful 12AX7, which is a known good tube. So I've got this set on 6.3, which is what I know it needs to be for the filaments. And in the calibration test, I found out that this octal socket over here is perfect for holding the probes. So I have that in pins 1 and 2. So I've got that hooked up. And there you can see on the meter, I'm reading 6.15. So now I'm going to tweak this knob here to get it up to 6.3. 6.3. Okay, so that's my filament voltage there. So I know pins 4 and 5 are my filament according to this. Type 1, 6.3 I've already tested, 20 on the load, and up. First test are 1 and 2, down are 3, 4, and 5. What if I do that? Okay, so you can see the tube actually warming up and it goes over here into the good range. Okay, so for the other triode in the tube, we do 6 and 7 in the up position and 4, 5, and 8 in the down position. I'll test that half, and again it goes over into the good. Okay, good enough. So I'm happy with it. I'm gonna quit messing with this thing and call it done. Well, this is going to conclude the series on the Knight Series 600 tube tester. It wound up being a really nice piece of test equipment to have here in the lab. And while this makes a great emissions tester, it doesn't do anything to test how well the tube amplifies a signal going through. For that, I built another tube tester test harness. I've built these before for like the 12AX7 and the EL84 in particular, but this one I made to be variable enough that any 7-pin tube that I could put in here, if it was a pentode, tetrode, heptode, triode, whatever the heck it was, I could stick it in here, and I have this universal gain stage set up, and I can adjust and set the pins for whatever they need to do. So I've got another video series that I'm going to go over this guy with. We can take a listen to some of those problematic tubes that were in this old tube radio to guitar amp conversion. And we can actually hear what each individual tube does to the sound of the guitar signal. That's going to be a lot of fun. And if you want to know more about this kind of stuff, do consider subscribing to the channel. I'd love to see you guys again in the future. So hope to see you there.